This video takes a look at the beginning of algebra called linear equations, the most basic type of equation, but really foundational to all of our study of algebra. The idea of solving is we're going to have some unknown part of an equation, and we need to find that unknown part. As we do that with linear equations, we really have three rules that solve all of our equations. The first is the most important, is that we must always do the same thing to both sides of the equations. As Mr. Dos Equis here tells us that he doesn't always solve equations, but when he does the same thing to both sides. Very important. As we're doing the same thing to both sides, opposite operations clear unwanted numbers so that we can get at that variable or that unknown part that we're looking for. And to decide what to do next, we actually work through order of operations backwards as we unwrap and unpackage that unknown value. So to set up how we solve these, I've got four really basic problems here to kind of get at the process we are going to use. That first rule was that we want to do the same thing on both sides of the equations. That means every problem is going to balance on the equal sign. A common error I see people do is they'll try to balance on the plus or minus signs. Don't do that. Balance on the equal sign. I like to draw the line. And here we have x plus 6, our unknown number plus 6 more. And to get rid of that plus 6, we need to do the opposite operation. The opposite of adding 6 is subtracting 6. And so we do that same thing on both sides so that the 6's subtract to 0, and all that's left is the x that we want. And we can see that x is equal to negative 4 minus 6 is negative 10. The second example, again, we're going to balance on the equal sign. X minus 3 equals negative 5. The opposite of subtracting 3, we'll do the opposite operation, which is to add 3 to both sides. Always the same thing on both sides, because negative 3 plus 3 subtract out to 0, leaving just the x is equal to our answer. Negative 5 plus 3 is negative 2. That unknown part is negative 2. Now this third example we need to be careful on because we see the negative 3 and we think, oh, we get rid of negative 3 by adding 3. But that's not how the 3 is connected to the x. The 3 is connected to the x. It's right next to it. So the 3 is connected by multiplication, which means to undo multiplication, we have to do the opposite, which is to divide by negative 3. And again, we'll balance on the equal sign and do the same thing on both sides. The negative 3's will divide out, and x is equal to 27 divided by negative 3 is negative 9. Our third example, we have our unknown value, which we call x, and we're going to divide that unknown amount by 2. Well, the opposite of dividing by 2 is multiplying by 2. And again, we'll balance on the equal sign, doing the same thing to both sides. Because 2 divided by 2 is 0, leaving just the, 2 divided by 2 is 1, leaving just the x. Negative 4 times 2 is negative 8. So these basic one-step equations kind of illustrate all the things we're going to do to solve. We're going to do opposite operations to get that x or the variable alone so we know what number that letter actually represents. Now usually these are going to be more complex. These two examples are what are called two-step equations because there's two operations happening to the variable. Here, the negative 3 is multiplied by the x and then added 4 to it. The answer we get is 10. We're still going to balance on the equal sign, and we'll keep in mind the order of operations of PEMDAS, parentheses, exponents, multiply and divide, add and subtract. But we're going to start at the bottom and work our way up when we solve, because we are undoing an operation. We're going backwards to our solution. Which means first we'll take care of any adding and subtracting. Which means first we need to take care of this plus 4. We get rid of the plus 4 with a minus 4, and we will do the same thing to both sides of the equations. 4 minus 4 is 0, so we're left remaining on the left side is negative 3x. Remaining on the right side, 10 minus 4 is 6. Now to get that x alone, it's negative 3 times x. The opposite of multiplying by negative 3 is dividing by negative 3. So those 3's are gone, and x is equal to negative 2. What's really nice about these problems is we can actually check our work. You can take this negative 2 that we found and plug it in for the x. Negative 3x times negative 2 plus 4, and hopefully that answer will be 10. Well, negative 3 times 2 is a positive 6 plus 4. Still hoping that's 10, and yes, sure enough, 6 plus 4 is 10. So we can always go back and plug that answer into the variable and see if it gives us the correct answer for what that variable, that x, represents. Let's try another example. Again, we'll balance on the equal sign. We've got 5 minus 4x equals negative 2. We have to get rid of what's added or subtracted first, and that's actually the 5 here is hanging out. We get rid of a positive 5 with a negative 5 on both sides of the equal sign. Leaves us with negative 4x equals negative 7. We get rid of that negative 4 by dividing by negative 4, the opposite of the multiplication. And this time the fraction doesn't reduce. We do have a negative divided by a negative, which we know makes it a positive. And our answer can be a fraction. That's just fine. Our fraction is 7/4. I'm going to check that by plugging it into the x here. So we've got 5 minus 4 times 7/4. Hopefully that will equal the negative 2 from the problem. What's nice about this is the 4's divide out. And so we've got 5 minus 7, which we hope will be negative 2. And sure enough, it is. So we are happy with our solution. 7/4 is the correct answer. Now, there's a few equations that kind of throw this curveball at us. They put the variable on both sides of the equation. You'll see in each of these examples, if we balance on the equal sign, the x is on both the left and the right. Well, the way we're going to fix that is we're going to always first, move all the variables to the same side of the equation as a block. So let's say we want to move in this one everything to the left. We've got this extra negative 2x on the right. She doesn't belong there, so the way we get rid of her negative 2x is we're going to add 2x, always doing the opposite, and always doing the same thing to both sides. Because 2x and negative 2x is 0, and now we have 4 plus 2 is 6x's minus 3 equals 9 is all that's left on the other side. Great. Now we're in business. We know we have to take care of that subtraction first by adding 3 to both sides of the equation. Because negative 3 plus 3 is 0. And we're left with 6x equals 12. Get the x alone by dividing the 6 out, because it's 6 times x. The opposite of multiplication is division. And x equals 2. Again, we can verify that answer by plugging it in. We're going to plug it into both of our x's, and hopefully both sides of the equations will come out to the same thing. So we've got 4 times 2 minus 3. Hopefully that's equal to negative 2 times x, which is 2, plus 9. We'll simplify both sides at the same time. Multiplication first. 4 times 2 is 8 minus 3. Hopefully that's equal to negative 2 times 2 is negative 4 plus 9. And sure enough, 8 minus 3 is 5. Negative 4 plus 9 is 5. Got the same thing. 5 does equal 5, so our answer of 2 is the correct answer. One more example here. This one, what I see a lot of people do on a problem like this is they say, hey, let's move the x's to the left side. So they subtract 3x, which is fine. 5x minus 3x is 2x plus 8, and then they don't know what to put on the other side. And sometimes magically the plus changes into an equal sign, and things just get weird. We can't do that. So let's back up. My suggestion is to always try and keep something on each side as we get used to solving these. So instead of moving the 3x to the left, let's move the 5x over to the right. So the opposite of a 5x, because that's positive, is negative 5x on both sides of the equal sign. That way we're left with 8 equals 3 minus 5 is negative 2x. Now it's really clear what to do. Negative 2 times x, we undo multiplication by dividing both sides by negative 2. And x is equal to negative 4. Let's test it by plugging it into both the x's. So we had 5 times x, or 5 times negative 4, plus 8. Hopefully that'll equal 3 times x, or 3 times negative 4. 5 times negative 4 is negative 20, plus 8. Hopefully that'll be equal to 3 times negative 4, which is negative 12. And sure enough, it is. Negative 20 plus 8 is negative 12. I'm happy with my answer. So the way we solve our linear equations, we're going to do the same thing to both sides of the equation, doing opposite operations to clear away the unwanted numbers until we end up with our variable, the unknown value, by itself. Take a look at the homework assignment. Good luck to you as you work on those problems, and let your instructor know if you have any questions.